Okay, so I'm doing solving the systems of equations, and it's based on the SOL standard 5. And in this, the student will solve nonlinear systems of equations, including linear quadratic equations and linear equations, algebraically and graphically. And graphing calculators can be used as a tool to visualize graphs and predict the number of solutions. And to figure out what the solutions are in the systems of equations, you need to know how to solve linear and quadratic equations, and we'll get to that later. For the definitions and formulas, a systems of equations is basically a set of or collection of equations that you deal with all together at once. They're also called simultaneous problems, where there are multiple sets of data happening at one variable. And a linear equation, or linear equations, are equations that graph as straight lines, obviously, and quadratic equations is an equation of the second degree and graphs in U-shaped lines, positive or negative. And the quadratic formula is used when you cannot factor a quadratic equation, so the quadratic formula is here. The quadratic formula, you are deriving your a, b, and c values from the quadratic equation. So if you had a 1 in front of the x, your a value would be 1. If you had a 2 in front of the other x, your b value would be 2. And say if your c value were 6, you do 6. And this memorization tool is from Better Than Your Professor on YouTube. A negative boy decides whether or not to go to a radical party. Being square, he decides not to go and misses out on 4 awesome chicks. The party was not over until 2 a.m. Okay, so we'll start solving the linear equations, but these textbook sections come from lesson 3.1 on pages 152 to 153. So these are linear equations, and first you have to solve for y. So you want to get y by itself, preferably on the left side, so you can put it into your calculator and find it graphically. 2y minus 4x equals 12. You're going to add the 4x to both sides. X plus 12. And then you're going to divide each side by 2, and this will leave the y alone. And the other one, and we'll use this for example 1 with a quadratic equation, but the other one is 4y equals 8x minus 8. So basically with this one, all you have to do is divide by 4. And we'll use that with example 2 with a quadratic equation. And these will be, we'll be solving a quadratic equation. It's 2y equals 2x squared plus 4x minus 2, minus 6. You just divide by 2, their equation, and you get y equals x squared plus 2x minus 3. And we'll use that with 2x plus 6. And for the other one, this is the last example. It's 3y equals 3x squared minus 3x minus 18. And these are not using the quadratic formula. Another question will. X minus 6. And that's that question. So these were the answers from question 1's on solving the quadratic and the linear equations. So what you basically have to do now is you need to type this into your calculator, and this is forming a quadratic linear equation. So when you're solving a system of equations, you're trying to find the solutions to the graph, to the system, and you might be asked how many solutions there are. In this one there are 2, or you might be asked what the apparent solutions are on the graph. And another way to look at these with the numbers are to type in second graph, and you'll find out your solutions by seeing from the y1 and the y2 list which match. So we see that one solution is 312 because in the list 1 it's 12, and the second list it's also 12. And then another solution I noticed was in the negative, and that's at -3, 0. So the solutions for this one is 3, 12, and -3, 0. So if you were asked that question on a test, you'd either put those answers in, or if you were asked how many solutions there were, you'd obviously put 2. And for the second example from the other questions, we got 2x minus 2 and x squared minus x minus 6. So you do the same thing and you type it into the calculator. And you go straight to the list on second graph. And you find that the solutions are -1, -4, and 4, 6, and to help you visualize, it's that on the graph. So the solutions to this one are -1, -4, and 4, 6. And there are 2 solutions in this system. And for the higher level question, we're going to be using the quadratic formula. It's really not that hard. You just have to memorize the quadratic formula. You obviously only put this one in the quadratic formula. So the a values is, that's A, that's B, and that's C. So the a value equals 1, and the b value equals 1, and the c value equals -4. So basically all you have to do now is plug it all into the quadratic formula. So the quadratic formula, as before, is -b plus or minus b squared minus 4ac over 2a. So the b value is, well, for this one it's -1 plus or minus radical 1 squared, which is 1, minus 4 times 1 times -4 over 2a. This is -1. You're going to start to simplify. This is 1 minus -16, which is really plus 16, over 2 times 1, which is divided by 2. So your zeros for this quadratic equation is -1 plus the square root of 17 over 2, or negative 1 minus the square root of 17 over 2. So that's that, and we already are given the linear equation. It's already solved for us. So all we have to do now is plug it into the graphing calculator. Okay. You don't have to do anything special with the quadratic formula in the calculator. It already knows. And we can go to table. And the solutions to this one is 3, 7, and negative 3, 1. No, 3, 7. And you have two solutions to that. And for the real life application problem, you can imagine a quadratic equation and a linear equation sort of as a line of best fit for a set of quadratic and linear data. And as said before, a system of equations is also called a simultaneous problem, which are multiple sets of data on one variable. So you can just think of it like that. And that's about it. You can also use it as when you're driving a boat and you're driving through bay boat markers and you want to, and say it's a linear equation. Obviously, you're not going to be using your calculator for it, but you can decide with the bay markers which side of the marker you have to drive, and therefore make a line of best fit as you move your boat through the bay markers. That's a wrap.